beginning our review video for Chapter 9, Section 5. So that's Section 9.5. As always, we start with our learning target. Our learning target for today is to use direct variation to solve problems. Well, we need to define what direct variation is. So direct variation is a relationship between two variable quantities with a constant ratio. All right, and that constant of variation is the name we give to that constant of variation or that constant ratio between them. Well, let's jump right in and do a problem here. The amount of money Sierra earns at her job varies directly as the number of hours she works. Determine the amount Sierra earns per hour. Well, as I look at this, I can see that the first value here is 4 hours of work for $40 worth of pay. So I've got $40 over 4. Notice I did put the y value over the x. It is the y value over the x that we use for our constant of variation. Well, $40 divided by 4 is $10 per 1 hour. All right, I'll check it here again. 8 hours worth of work for $80 worth of pay, so 80 over 8 reduces to $10 per 1 hour. So we're on a roll here. It looks like it's going to check out. If she works 12 hours and earns $120, remember the y value goes in the top, so in the numerator, so it's 120 divided by 12, or $10 per 1 hour. That checks out. We'll do it one more time. We've got $160 in 16 hours, so $160 over 16 hours reduces to $10 per hour, so I think her wages are $10 per hour. It is a direct variation and it's constant. The amount of money Elizabeth earns at her job varies directly as the number of hours worked. Determine the amount Elizabeth earns per hour. Well, I'm going to pick some ordered pairs, and I've got to pick quite a few to make sure they work here. I've got 1 hour's worth of work earns her about $15, so 15 over 1 becomes 15, stays at 15 over 1. 2 hours worth of work gets her $30, so 30 over 2 reduces to 15 over 1, so it's checking out. 3 hours worth of work earns her about $45, so 45 over 3 does reduce to 15 over 1, looking pretty good here. 4 hours worth of work earns her $60 worth of pay, so 60 over 4, and it also reduces to 15 over 1. So she earns $15 per hour, answer D. All right, here's a key concept review. A direct variation is a relationship in which the ratio of y to x is a constant, and we name that constant k. We say y varies directly with x. So our constant k is y divided by x, and it needs to be the same for all of the ordered pairs that are up there. All the ordered pairs that come from the line. Well, let's look at this particular line. All right, if we look at 1 hour worth of work, or an ordered pair of 1 comma 3 here, so the ratio of y to x would be 1 over 3, so our constant would be, constant k would be 3. We can then take this equation, we can say k is equal to y over x, or 3 is equal to y over x. We can multiply both sides by x, and we can get y is equal to 3 times x, and that becomes the equation for this direct variation. The total cost for cans of soup varies directly as the number of cans purchased. If 4 cans of soup cost $5, how much would it cost to buy 8 cans? Well, the y value here, right, is going to be $5. The x value would be the 4 cans of soup. So our constant here would be $5 over 4 cans, or our k would be equal to 5 divided by 4, or $1.25 per can. All right, so that means our equation then, y, which is the cost, is equal to the constant k, which is $1.25 per can, times the number of cans purchased, which would be x. If I'm going to purchase 8 cans, I plug 8 in for the x, and I say y is equal to 1.25 times 8, 1.25 times 8 is $10. So it cost me $10 to buy 8 cans. Cost of apples vary directly as the number of apples purchased. A grocery store sells 6 apples for $2.70. How much would it cost to buy 10 apples? Well, again, I'm looking for my constant. My constant would be equal to $2.70 divided by the 6 apples that purchases. So if I'm going to look at, and on my calculator, I'm going to take $2.70 divided by the 6 apples. And I get 45 cents, 0.45 cents, or $0.45, $0.45 per 1 apple. So that's my constant K. My equation then Y is equal to 0.45 times the number of apples purchased, or X. So Y then would be equal to 0.45, and in this case they told me they want to buy 10 apples, so I plug 10 in for the X. I take 0.45 times 10, and I get $4.50. As I look at this one, determine whether the linear function is a direct variation. If so, state the constant of variation. Well, for this to be a direct variation, it means that this ratio must be equal to this ratio, must be equal to this ratio, and must be equal to this ratio. So I'm going to say that the Y value in that first one is 16 over 2. 16 over 2 is, of course, 8 over 1, or just 8. In the next one, it's 32 over 4. Okay, 32 over 4 reduces to 8 over 1. So it's looking good. The next one would be 54 over 6. However, 54 divided by 6 is 9. So it's 9 is the ratio. So I have a constant of variation 8, a constant of variation 8, and now a constant of variation 9 cannot be. So this is no, it is not a direct variation. Determine whether the linear function is a direct variation. If so, state the constant of variation. Well, again, I check these ratios each time to see if they're the same. 8 over 1 is equal to 8. 16 over 2 reduces to 8. 24 over 3 reduces to 8. And 32 over 4 reduces to 8. So it looks like it is a constant or a direct variation, and its constant of variation is 8. So letter B is my correct answer. Determine whether the linear function is a direct variation. If so, state the constant of variation. Well, as I look at this one, again, the ratios have to be constant for it to be a direct variation. So it would be 25.5 over 3. I need to reduce that so I can compare here. So I'm going to go to my calculator, and I'm going to take 25.5 divided by 3, and I get 8.5. I'm going to do the next one, which is 51 divided by 6. And that also comes out to be, so it'd be 51 divided by 6, which also comes out to be 8.5. So it's looking pretty good, but we got to continue on and check them all. All right, so we got 76.5 divided by 9. And that also comes out to be 8.5. And 102 divided by 12 comes out to be 8.5. So this is a direct variation, and its constant of variation would be 8.5. Determine whether the linear function is a direct variation. If so, state the constant of variation. Well, the ratios have to be the same. That's what we're doing. 12 over 2 is equal to 6. 25 over 4 not equal to 6. It is not equal to 6. So this is no, it is not a direct variation. Not a direct variation. All right, concept summary. Here we've got The table that shows the ordered pairs X and Y shows the ordered pairs X and Y, and then it shows the ratio of Y to X. And you can see if it is a direct variation, the ratio is the same. If the ratio is the same, then it does look where it crosses. All right, here's a graph. It is still a straight line. All right, here's the X's and the Y's and the ratios. The ratios are not the constant, and please notice that it does not go through the origin. It does not go through the origin. Thank you.